So what kind of image should be formed when the object is located between F and 2F? Again, like the earlier examples, we will always consider these 4 points: the nature of the image form, the orientation, position, and size. Now, again, the image is formed on the opposite side of the lens. And when it's formed on the opposite side of the lens, by tracing the three basic light ray diagrams, you can cast this image onto a screen. So, formed on the opposite side of the lens, and this image can be cast on the screen, we consider this image to be real. I say again, the image is cast on the opposite side of the lens and can be cast on the screen. So this image is real. And the orientation. When we talk about the orientation, we must always compare relative to the object. Now, this can be seen by looking at the arrow on the object to illustrate its orientation, and the arrow on the image. And by comparing these two arrows, we find that the image is now inverted. Please avoid the word upside down. Alright, it's just inverted, and it's inverted because you're actually comparing relative to the object. How about the position? The position of the image is now beyond 2F. Okay, the position of the image form is now beyond 2F. Now, I'd like to point out, with reference to an earlier video, in this video, the object is located between F and 2F, and the image is now located beyond 2F. Now, in an earlier video, this object is located beyond 2F, and now the image is between F and 2F. Okay, slowly try to find this pattern to make your learning much easier. Now, how about the size? If you look at the size of the image, you can see that it's a lot bigger than the object itself. Right? Again, for size, we compare relative to the image, to the object. So the image is now bigger than the object. So you can say the image is enlarged, or the image is magnified, or the image is larger than the object. Compare reference to the object.